Alrighty, so what I would like to do is have a look at the questions and answers whenever you need to go, Corey. Okay. Kinematics questions there. I'd like to do 1 to 14, and then I'm going to give you the rest of the time to work on some problems today. So, does a car's speedometer measure speed, velocity, or both? Only speed, because if it was velocity, you'd have to include the direction, which would mean you'd need the compass part, right? So the speedometer is just the speed. If an accurate speedometer registers a constant value for a period of time, can you determine the average velocity over that period of time using only the speedometer? I got to read that again because I really was paying attention to myself. If an accurate speedometer registers a constant value for a period of time, can you determine the average velocity over that period of time using only the speedometer? Once again, no, of course not. Why not? You need, yeah, that's right. You need the direction. Right, you are, Justin. You need the direction as well. Okay, what about number 3? Can the average velocity of a particle be 0 over a given time interval if it's not 0 over a shorter period of time? Can the average velocity of a particle be 0 over a given time interval if it's not 0 over a shorter period of time? In other words, could you have a speed now, and a speed now, and a speed now, and a speed now, but the average velocity be 0? And Matthew says yes. How come? As long as the total displacement is, then the average velocity is exactly right. So you could have various speeds, right? But if this is number 3, right? If the overall displacement is 0, then that means that the average velocity is 0, right? Even if you just go out and run around the track once, right? You're going to have a speed all the way around, but your average velocity is going to be 0. Very good. Can an object have varying velocity if its speed is constant? Can the velocity be varying if the speed is constant? Hunter says yes. Exactly. On the highway at constant speed, making a corner, right? Absolutely. Absolutely. So answer number 4 would be yes. And an example would just be driving a car and going around a curve. Can an object have varying speed if the velocity is constant? Can the speed be changing if the velocity is constant? And the answer there is no. How come? Because if the velocity is constant, that means both the speed and the direction have to be constant. When an object moves with constant velocity, does its average velocity during any time interval differ from its instantaneous velocity at any instant? Object is moving at a constant velocity, so constant speed, straight line. Does its average velocity during any time interval differ from its instantaneous one? No. How come? Exactly. That's what constant means. Right? Constant means it's always the same. So it can't be different. Number 7, can the velocity of an object be 0 at the same instant its acceleration is not 0? Ooh, this one's a little bit harder, I think. Can the velocity of an object be 0 at the same time its acceleration is not 0? What do you think, Riley? Not sure? Number 7. Darren's thinking, I can see. Jesse, what do you think? Okay. Yes, it's possible. The velocity of an object can be 0 if the acceleration is not 0. And we did actually see that the other day when we were rolling the, when Justin was rolling the cart up the ramp, right? It went up to here, and then it went back to there, right? And the velocity time graph, I think, went from positive. It was something like that, I think, right? But the acceleration the entire time was the same, right? When the cart goes up at the very top right here, what's the velocity? 0, right? When it's at its peak right there, it's 0, and then it goes back down the ramp, right? Okay, but the acceleration is always the same. Another example would just be me taking that pen and throwing it up in the air because I'm mad, like I did yesterday. If I could find my tennis balls, right? If I toss something up in the air, right at its peak right here, velocity is 0, but the acceleration is still minus 9.8. So the answer is Yes. Fired it. That's what I just did. Yeah, it didn't satisfy my need to be. Yeah. Number 8. If a car has a greater maximum speed than another, does it mean that it also has a greater acceleration? Not necessarily. Not necessarily. If a car has a greater maximum speed than another, does it mean that it also has a greater acceleration? No. Number 9, compare the acceleration of a motorbike that accelerates from 80 to 90 with the acceleration of a bicycle that accelerates from rest to 10 in the same time. So they would be I didn't actually write an answer for 8, did I? Come back to 8. Compare the acceleration of a motorbike that accelerates from 80 to 90 along with a bicycle that goes from 0 to 10 in the same time. They would be the same, would they not? Right? They each change by 10 kilometers an hour in the same amount of time. They would have the same acceleration. The answer to 8 was no. Number 10, can you conclude that a car is not accelerating if its speedometer indicates a steady 60 kilometers an hour? They keep asking the same question over and over. Carly, what do you think? Can you say that it's not accelerating if the speedometer indicates a steady 60? You can? Think about driving around a corner again, right? It would show constant 60, but you would be accelerating. So the answer would be, no, you cannot conclude that. Well, you could, but you would be wrong, I guess. That's for quitters. Can an object have a northward velocity and a southward acceleration? Can you be going north and have a southward acceleration? Absolutely. Walking north and slowing down, right? What do you mean, no, no, no? You know, you're driving along the highway to go see Justin. Is it Sifton or Fork River, Justin? Fork River. We're going to Fork River, see Justin. We're driving north on the highway. We have a northward velocity. We miss the turn and we have to slow down, so our acceleration is? Our velocity is to the north and our acceleration is to the south. Number 12, can the velocity of an object be negative when the acceleration is positive? It's the same question as number 11, exactly. Absolutely. All it means is slowing down. Number 12 is the same as number 11, and it just means slowing down. Can you give an example where both the velocity and acceleration are negative? For example, I take Justin's iPod and I drop it on the floor. I wouldn't do that to you. Right? But the velocity is down, the acceleration is down. So, give an example of that. All that is just dropping something. A rock is thrown, now here's where they start to get a little bit harder. A rock is thrown vertically upward with a speed v from the edge of a cliff. A second rock is thrown vertically downward with the same initial speed. Which rock has the greater speed when it reaches the bottom of the cliff? I'm going to draw this picture. You said they were the same, Matt? Okay, let me just draw it over here. A rock is thrown vertically upward with a speed v from the edge of a cliff. So here's the cliff. The rock is thrown up at some speed v. Vi, I guess. A second rock is thrown vertically downward with the same initial speed. So the second one here in blue, and just for in purposes, I'll show it being thrown like this. Which rock has the greater speed when it reaches the bottom of the cliff? And you say they are the same. And I think he's right? Because when it goes up, right, it starts off at some speed right here, let's say 5. It goes up until it gets to velocity of 0. Then it starts coming back down. How fast is it going right there? 5, right? It's gone just as far, it's accelerating the same. So in effect, you are actually throwing it down at that speed, right? Now, which one lands first? The red one or the blue one? If you did them both at the same time. The one that you went, the blue one down, right? Yeah, this one would obviously get there faster, but they would be going the same speed when they landed. That is kind of neat. Can I keep going? Did anybody get past this? You quit?
You're a quitter.
Okay, you know what I'll do is I will give you a little bit of time, and then about 10 to 10 or so, I'll finish them off. How's that? Okay, so you guys keep going. If you want to work on some of the problems there as well, I'll give the answers up to, how many are there altogether? Up to 18? Okay. I'll do those in a while. You guys can have some time to work.